UTME Physics practice problem. I'm currently on question number 6. So question number 6 says that if we have masses m1, m2, which are in simple harmonic motion, such that m1 swings up and down on a helical spring of spring constant k, and m2 swings to and fro on a simple pendulum of string length L. If the masses have the same frequency, what is the length of the string? So we have been told that m1 is here swinging on an helical spring, so this is m1, and then we have mass 2 swinging in a simple pendulum to and fro, so this is m2. Now these two guys have the same frequency, and that is where we're going to start solving the problem from. One thing about frequency of helical spring is that it's given as 1 over 2 pi square root of k over m, and for the frequency of this guy that is moving in simple pendulum, it's also given as 1 over 2 pi square root of g over L. So what you notice is that, so this one will be m1. This simple pendulum, the frequency does not depend on the mass. But for the helical spring, the frequency and the period depends on the mass. They've told us that the frequency, they are the same. So I can equate these two together. And if I equate that, that means that 1 over 2 pi can get away. And since square root of k over m1 will now be square root of g over L, that implies that k divided by m1 will be equal to g divided by L. What I'm trying to look for is L. So if I just cross multiply here, I have that KL equals GM1, and that would imply that L equals M1G all divided by K. So the correct answer to this question will be option D. So that's basically how to solve that. Now question number 7 says that a length is measured as 2.450 centimeters. The number of significant figures and the possible devices used are. So to measure significant figures, for significant figures actually, if we have, let's say, something like 2450, this 0 will be insignificant, and this would have been 3 significant figures. But when we have trailing zeros like this, that is zeros that are ending, but there is a decimal point somewhere in between this whole thing, then the 0 is actually going to be significant. So indeed, in this place, the 0 is significant. So we have 1, 2, 3, 4. 4 significant figures altogether. And this reading is taken by the micrometer screw gauge, because when it comes to the micrometer screw gauge, it can actually measure very, very accurate length, just that the length has to be very, very short. And then since this length has to be very, very short, that's the only disadvantage it has. It cannot measure over a long period, but its accuracy is actually much more better than that of the vernier caliper, and also than that of the meter rule itself. So this is for the micrometer screw gauge. In centimeters, you have 3 decimal places, and in millimeters, so this is for centimeters, and for millimeters, it measures to 2 decimal places. That is for the micrometer screw gauge. So the correct answer here is going to be B. So you can also learn for the vernier caliper, and then you can learn for the micrometer, the meter rule as well. You can check some of my previous videos. So the correct answer for this one is B. Let's move to question number 8. Question number 6 is that if time is doubled and length is halved, what will be the percentage increase or decrease in the quantity whose dimension is given as this? So the quantity is what? LT raised to negative 2. Let's write that in a better way. This is L over T raised to power 2. That's basically what this thing means. So you say that if the time is doubled, meaning that the new time now, so we're going to have a new time, T2 is going to be 2 multiplied by the original time. Then what happened to the length? The length was halved. So that means that the new length is going to be half of the original length. So let's see what we have now in this quantity. So using this same result, L over T squared, just that this time around we have L2 over T2 squared. What is L2 now? L2 is 1 over 2L. And what is T2? T2 is what? 2T raised to power 2. And that will be 1 over, so this 2 will come down. You have L at the top. But this 2 will be squared. That will be multiplied by 4. So 2 raised to power 2 is 4. Then you have what? You have T squared here. And what would this be? 1 over 8 what? T squared. So that means that this thing has moved from what? From this to this. It has reduced to 1 over 8. So we are going to be looking for percentage decrease. However, What we are looking for is not what it has decreased to. 1 over 8 is 0.125 in this case. If you press that on your calculator, let me quickly press my calculator so I can confirm that. So 1 over 8 is 0.125, and to get the percentage equivalent of that, I will multiply it by 100. So this thing has actually decreased. So it has decreased to 12.5%, but that's not the question they're asking us for. They're asking for what is the percentage increase itself. So the percentage increase, so this time around is not percentage increase, it is percentage decrease. The percentage decrease will be how much decreased from this guy before it became this. Total percentage is 100, so you just subtract this percentage from 100% minus 12.5%. And that is going to be 100 minus this. So that's going to be 87.5%. So the correct answer to this is option A. It's option A, so I've sort of placed option B alongside, but it's 87.5%. Let's solve question 9. Question 9 says that a body moves in a circular path of radius 2 meters with a total of 2.25 oscillation. Its displacement from its starting point is. Now, you see, this kind of question, it's asking us that if a body is moving in a circular path, so permit me to just take this up a little bit. So it's moving in this circular path. Then it has gone through, the radius of this path is 2 meters. Let's leave it there like this. So it says that the total oscillation is 2.25 oscillation. So let's assume that it starts from here. What is the meaning of 2.25 oscillation? 2.25 is actually the same thing as 2 whole number 1 over 4, because 0.25 is 1 over 4, meaning that it has gone 2 oscillations and a quarter oscillation. And what does that mean? So if the body is starting from this place, so let me change the color of my pen. If the body is starting from here, so the body would have gone around, made it back here. That's the first oscillation. Then the body can go again and go like this. That is the second oscillation. But it says that the next oscillation is not a full oscillation, it's a quarter oscillation. That means that if you just make it from here, let me draw it out here, to somewhere around here, and a quarter oscillation will be something of this nature. It will just cover, so starting from this point to this point. It's like we are dividing the entire circle into 4 quarters. And when you look at that very well, this angle here will be 90 degrees. What are we looking for? We are looking for the displacement from its starting point. Displacement is simply the straight line that joins the starting point and the end point. And so all we need to look for is the distance from here to here. Now, radius is always uniform, so the line from here to the circumference, from the center to the circumference, is 2. Also from here to the circumference is also 2 as well. So what we're looking for, which is the displacement, is going to be the length of the hypotenuse. And if you know your Pythagoras theorem very well, so you know that the displacement will then be square root of what? 2 squared plus 2 squared. And that will be what? Square root of 2 squared is 4, 4 plus 4 is 8. And square root of 8 is square root of 4 times 2, which will be 2 root 2 meters. So the correct answer to this question is C, 2 root 2 meters. Now, let's quickly answer question number 10 before I end this video for today. So I believe you can always go back to the video to check this, because I'm going to erase some of this thing now so that I can have enough room to solve the next question. So you can just pause the video, screenshot the solution, and watch it. So in case you still need some of this right up. Okay, just a second, please. Okay, so question number 10. Question number 10 says that in a 2D plane, a particle moves from point 2, 3. A particle moves from point 2, 3 to a point -4, 11, and then, so let me change the mark. Let me change the back. So from point 2, 3 to a point -4, 11, and finally stopped at a point 5, 7. So this is the journey. The journey started from 2, 3. The journey made it to -4, 11. Then it stops at 5, 7. So if you stop at 5, 7, so we have that. Yeah, let me just shift that a little bit. we have that the distance and displacement of the body respectively are. You see, for distance, you need to calculate every single distance in this place. So that means that you need to calculate the distance covered from this point to this point. You need to calculate the distance covered from this point to this point, and you have to add them together. So how do we do that? So when you are given point like this, to find the distance is just going to be square root of x2 minus x1 squared plus y2 minus y1 squared. That will be the formula for the distance. And so let's quickly label that. So in this case, we have what? The left hand side will be the x component. So this will be the x1, this will be the y1, and this will be the what? X2, and this will be the y2. So when you put that into this, so you have square root of what is x2? Negative 4, x, this is negative 2 squared, plus what is y1 here? 11 minus 3 squared. And that will be square root of, this will be negative 4, negative 2, that will be negative 6 squared, that will be 36, plus 11 minus 3 is 8, 8 squared is 64. 36 plus 64 is 100, so square root of 100 is 10 meters. I've gotten the first distance. So I'm going to relabel this now. This will be my new x1, y1. This will be my new x2, and this will be y2. So the distance for the second phase will be the square root of 5 minus negative 4 all squared. I hope you are paying attention to that. Then this will be y2 is 7 minus 11 all squared. And that will be square root of 5 minus negative 4 is 9. So 9 squared is 81. 81 plus 7 minus 11 is negative 4. Negative 4 squared is 16. So what I have here is square root of 97. So square root of 97, let me quickly press that on my calculator. Square root of 97 is approximately 9.85. Is 9.85. 9.85. So that we don't get confused. So 9.85. So to get my total distance covered now, that will be D1 plus D2. And that will be 9.85 plus 10. And that will be 19.85. So total distance covered is 19.85 meters. Now for the displacement, we do this exact same thing, just that displacement is only going to deal with the starting point and the end point. So the starting point now, we're going to be using this point 2,3 and this point 5,7. So the displacement is going to be square root of, so in this case, what is my x2? My x2 is 5 and my x1 is 2. So that will be 5 minus 3 squared. No, I think that was 2, sorry. 5 minus 2, it should be 5 minus 2 instead. So 5 minus 2 squared plus, so in this case, my y2 is 7, my y1 is 3. So that will be 7 minus 3 squared. And that will be square root of 3 squared plus 4 squared. Square root of 3 squared is 9. So that's 9 plus 16. That's square root of 25. So the displacement is going to be 5 meters. So when you look at the options of this question, we got our total distance covered was 19.85 meters and the displacement was 5 meters. So in these options, there are no correct option. So the correct option is 19.85 meters and 5 meters. So that's the total distance covered and the displacement of this object. So I'm going to be stopping here for today. Make sure you like, comment, and follow if you want to continue to see the solution to these videos. I'm going to be posting the next set of solutions tomorrow, starting from question number 11. We have 70 questions in total. So, and I've been solving it from question 1. You can check the previous video as well and share with your friend. I'll see you in the next one.